This is Agriculture Today, and I'm Shelby Varner with the K-State Radio Network. K-State's Drew Ricketts and Joe Gerken start today's show with another episode of Fins, Fur, and Feathers. This week, the pair discuss invertebrates and what they contribute to the environment. Dorivar Ruiz Diaz, K-State soil fertility specialist, keeps the show rolling by explaining the value of soil fertility and what he recommends for growers who are trying to use minimal amounts. Ending the show is K-State dairy specialist Mike Brouk as he talks about recently published numbers by the USDA Economic Research Service on expected prices for raw milk for 2025. That and more is coming up ahead on Agriculture Today. You're tuned in to Agriculture Today, and we start our Tuesday show with another episode of Fins, Fur, and Feathers with K-State's Drew Ricketts and Joe Gerken.
Welcome back to Fins, Fur, and Feathers. This week we've got an aquatics episode. Joe, are you going to talk about something that gets wet?
I am, yes. We're going to talk about bugs today. I'm getting ready to go to a conference where we're going to spend a lot of time talking about bugs, but invertebrates, which we'll refer to as bugs for most of this talk here, are important components of aquatic systems. So I thought we'd spend a little time chatting about them today.
Sure. Well, I know not all invertebrates are bugs. So what makes an invertebrate, I guess?
Yeah, that's true. They're not all bugs. There's lots of different varieties. So an invertebrate just is an animal without a backbone, right? And so when we think about that, a lot of times we're thinking about what we would call bugs, but that's not always the classification. And so there are two main groups. Microinvertebrates are small animals, so they can be single-celled. They can be up to multi-celled. Little plankton is how we would refer to them a lot of time, but they're going to be small enough that you're going to have a microscope to see them. They can be really important. They feed a lot of fish, a lot of really big fish. Some of the biggest whales in the ocean, for example, feed entirely on these tiny little animals. So they can be really important. They're the base of the food web in a lot of systems, but they're really hard to see, and they're kind of their own little class. Today we're going to focus on what's called macroinvertebrates. And macroinvertebrates are invertebrates that are big enough to see without a microscope. So you can pick them up. They still might be really small, but you can see them with your eyes. And so lots of different groups even there. We can talk about invertebrates that look like or act like bugs, for example. But if we think about a clam or a freshwater mussel, those would be invertebrates. A crayfish is a freshwater invertebrate. So lots of different groups of invertebrates. Today we're going to focus primarily on those macroinvertebrates in aquatic settings.
You mentioned that there's a lot of different kinds of invertebrates, but, really if we get down to the nitty-gritty, how many kinds are there?
Yeah, so in science we use taxonomy to kind of group different animals, and one of the taxonomic groups is an order, and an order is kind of saying, hey, there's a big group here that all kind of have some similarity, and there's 10 different orders. If we break it down, there's about 70,000 different aquatic invertebrates that have been described, and so that is a really large number, but that's estimated to only be about 10-20% of all the aquatic invertebrates, freshwater invertebrates that are out there, and that might even be too high of a number. There's a lot of invertebrates out there that just have the incredible diversity, and we haven't had the chance to identify them all yet, especially if we start thinking about, remote areas that these animals might be at. So there's a ton of different animals, but if we break them down, there's 4 main groups, and those are, I'm going to describe them based on their functional feeding group. That's one of the ways that we describe these different invertebrates. So there's 4 main groups. The first group are called grazers. And so these grazers kind of slide along. They have like a raspy mouth a lot of times, kind of like sandpaper if you think about it. And they kind of scrape surfaces. So they might scrape a rock, for example, that has algae growing on it and clean it off. So those grazers are fairly common. Ephemeropters and snails are the biggest group there. Another really cool group are called collector-gatherers, and these are really cool because they're collecting stuff that might be kind of washing through the system. If we think about a system where water is running, a stream, a creek, a river, something like that, there's a lot of suspended particles, and these groups, can go out and they make little nets, a lot of them, and it's going to filter that water just like a net that we would put in the water, and they're going to collect a bunch of little detritus, biofilm, little pieces of particles, and then then they go out on their net, and they kind of do that same thing. They graze back and forth on that net, but they're collecting particles that are drifting. The next group would be shredders, and so these are really important. Another big word is allochthonous inputs. So allochthonous means it's outside of the water itself. So if we think about leaves in the fall, falling into a stream or a pond, they have to break down somehow, and one of the ways that they do that is by getting torn up into little pieces or cut into little pieces. So arthropods, crayfish are a good example of that, where they'll go out and they'll cut up a lot of little leaves or input that's coming from outside the system. And that's really important because as they break that down, that increases the surface area for bacteria to get on that leaf or whatever the material is. And it allows that process of breaking down that organic material to kind of, move at a faster pace, a pace that, over seasons, we're not getting too much input in the system, for example. We can start to break it down. So I think the last group always surprises people. When we're talking about invertebrates, there's a whole group out there that are predators. And so they'll sit there. A lot of them have forelegs that can help grab onto animals. They have mouth parts that can pierce into animals. And so a dragonfly larvae, for example, can grab onto a little fish, and it can grab onto it with its legs, and it can pinch it on the sides and immobilize that fish and eat the fish. And so when we start talking about an invertebrate eating a fish, or what we would call a water bug eating a fish, just always exciting and surprising that those types of animals are out there.
You talked a little bit about the value of some of these aquatic invertebrates, as sort of working as the cleanup crew, helping to break down that organic matter and that sort of thing. What else are they good for? Why should we care about them?
Sure. A couple other big things they do. One of them is that they're really important in food webs and aquatic systems. And so if we think about those little fish, larval fish, need to have something to feed on, and a lot of times it's invertebrates that they're feeding on. So entire food webs, if you take out invertebrates, the food web's going to collapse. You're not going to be able to have fish if you don't have these invertebrates in the system. So understanding the importance of them feeding other organisms is really beneficial. It can also be indirect feeding. So they might make some resources, break down a leaf, for example, into little pieces that then can be utilized by another organism, where it might be too big if it was the whole leaf they were trying to consume, but a small piece of that they might be able to. So some benefits there, breaking down that organic material. They can help sometimes with algae control. This is especially common in like little small backyard ponds. So it'd be hard to do in a 1 acre pond or something really big. One of the really good ways that we use them as scientists is to look at water quality. And so it's a little bit antiquated at this point, but there's this idea that you can go look at invertebrates, and it's called the EPT index, Ephemeroptera, Plecoptera, and Trichoptera index. Go look at the ratios of different invertebrates, and it'll tell you the relative health of a river or stream based on their abundance. And so if we're doing that, if we're going out to our pond and we don't see any invertebrates, that might be an indication that there's something going on, something we'd want to look at.
So is that something that somebody could actually buy, an aquatic insecticide to kill off the bugs in their pond?
Yeah, you'd see that more likely with snails, for example, where they make products that can do that. A lot of times it's unintended consequences. So you might be spreading an insecticide around the edge of your pond, for example, and that can get into the water itself. These aquatic invertebrates are even more susceptible to a lot of those chemicals than the terrestrial counterparts. They're absorbing a lot of the way they breathe can be through gills or through their skin, and so they can just absorb a lot of the chemicals a lot quicker. So smaller doses can be really detrimental to them, and understanding the implications could be a problem. There are times, like if you're overrun with certain types of snails, the only way to fix that would be either to drain the pond or add some chemicals. So there might be times to do that. We just want to make sure that we have a good thought out plan. We've talked to a professional about it before we go and do something like that.
So, Joe, you mentioned that, a lot of these aquatic invertebrates are, as adults, insects that might be able to fly, and so they can get to ponds that way. Sometimes I'd be walking around out in the pasture, and there'd be dead bluegill or dead green sunfish just out in the middle of the pasture, and I didn't really understand how that happened. And one day I was out in the pasture during a great big rainstorm, and there was sheet water throughout the whole pasture, and I could see these little bluegill and green sunfish swimming across the pasture. And so, that makes me think about another way that stuff can get into aquatic environments in different places.
Yeah, those flashy events where you get a rainfall, the water comes up so much. You might have an entire field that's covered in an inch or two of water. It might only be like that for 10, 15 minutes, but those fish take advantage of that. Those flooded habitats a lot of times have a lot of invertebrates or energy that they can utilize. So they might go out there looking for a place to eat or a place to get some mating. It might be a mating habitat. So different things that they can do in those environments, and it's really cool. Those high flow events can also cause something called invertebrate drift. And there's a couple types of invertebrate drift, passive and active. So when we're thinking about high flow event, pushing those invertebrates that may be hanging out on a log or on the substrate or something, you get a big flood come through and it just pushes them downstream. There's also, a kind of an active event where the bugs decide to do this. And we see this a lot in streams and rivers during dusk and dawn. If you go out and set a net out there, a lot of bugs just kind of decide that, hey, they're tired of living where they're living, and they just jump up into that current and they get pushed downstream. And so that movement, that invertebrate drift, the numbers are 10 or 20-fold what you would normally see. Huge spikes in the amount of invertebrates drifting downstream. That can provide a lot of opportunities for fish to feed. It also moves those invertebrate populations downstream. So that terrestrial movement, again, repopulating those areas where the adult insects emerge and go disperse their eggs, really important for making sure invertebrates stay everywhere in the systems.
Once again, that was K-State's Joe Gerken and Drew Ricketts. I will link the full Fins, Fur, and Feathers episode in today's show notes on agtoday.net, or you can find it on the podcast streaming platform of your choice. We're cutting to a short break now, but stick around because we have more for you ahead. You're tuned in to Agriculture Today, and we continue our show talking about fertilizer with K-State Soil Fertility Specialist Dorivar Ruiz Diaz. Dorivar, thanks for joining us today.
Thank you.
Dorivar, as we're thinking about fertilizer, first, really important to see what's already in your fields.
Yes, as we're thinking about fertility program for winter wheat this fall, and keeping in mind that grain prices are lower, obviously can affect how we manage fertility this season. We do have some opportunities in some cases, and that's exactly the type of things that we need to think about now. You just mentioned we need to know exactly what we have in the soil, and that's going to be one key aspect this season. Those are situations where perhaps we can have significant savings in fertilizer. If we start with nitrogen, which is typically the most limiting factor for winter wheat, we need to be thinking about what we have in the profile. Do we have any nitrogen already there that we can the wheat crop can use in the coming months? And so this is key information we need to have. Of course, we need to be also we need to make sure we meet the needs of that crop when it comes to nitrogen. We have to keep in mind that nitrogen is often the most limiting nutrient, and wheat is a very responsive crop to nitrogen. And so if we are thinking about, again, with the low grain prices and thinking about maybe cutting back on fertility, we have to be careful there, because in the case of nitrogen, we can have the opposite effect, that we're cutting too much. Obviously, yields are going to be affected significantly. And of course, we don't want to have that combination of low grain prices and low yields. Of course, we need to look at the economic optimum here. So in some cases, of course, we do have, we need to be adjusting that nitrogen rate a little bit. But again, not be too aggressive there. One key aspect also to think about when it comes to nitrogen is, do we have ways to improve nitrogen use efficiency? What tools we have available to improving the efficiency of that fertilizer that we apply? Again, maybe not so much in terms of cutting significant rates, but can we do a better job in terms of placement of that nitrogen, timing, using different sources? Those are the things that we need to be thinking about. All of those are going to be contributing to increasing nitrogen use efficiency. Of course, again, we do have some time for nitrogen. Fair amount of this is going to be going top dressing, so we do have a little bit more time on this. Do we need to be thinking about, again, like I say, different placement or timing, using perhaps some additives alternatives. If we do have some potential nitrogen losses in some fields, those are going to be things that we need to think about. And to me, I think those are even more relevant than, again, thinking about cutting back rates. And at the same time, also, we have to be looking at what's really proven practices that's going to be returning into improved efficiency and improved yields. There's a lot of options there that, in the market that we are looking, especially for nitrogen, that maybe are still early stages, that maybe don't have the research to back it up. And again, we need to be looking at that very closely. But as we're thinking about this fall, for sure, again, looking at that soil testing, of course, nitrogen is a mobile nutrient, so ideally we want to look at profile 24 inches. And of course, again, we can look at other mobile nutrients at the same time, things like sulfur and chloride, which could be a limiting factor as well. And again, this is a time of the year to be thinking about these.
And is this something sampling needs to be done so that a producer's not just out there maybe putting on too much nitrogen?
Absolutely, and this is the key. Of course, this year we don't want to be putting more than what we need. We really want to be as close as possible to that optimum. And again, in many cases, we may have an opportunity here if we already have some residual nitrogen that we can use for that wheat crop.
And Dorivar, you said there's some flexibility when it comes to applying nitrogen. However, something that really needs to go ahead and be decided on, phosphorus.
Absolutely. This is a really good point. This may be a little bit more critical for us right now because phosphorus is a nutrient that needs to be applied either pre-plant or at planting. And so we need to make that decision now. Winter wheat is a very responsive crop to phosphorus. So keep this in mind as we're making decisions. Of course, again, going back to soil tests, we may have opportunities. In some cases, some producers tend to keep soil tests a little bit on the higher side just to manage that better. And so it may be possible that in some fields we may not need to put any phosphorus or maybe just a very low rate as a starter fertilizer this fall. And again, given the tight budgets, that would be great. I mean, this is an opportunity in the case of phosphorus. One other thing that to think about phosphorus, especially for winter wheat, is that a little bit also thinking about efficiency. How can we be more efficient with that phosphorus fertilizer? Especially if we put in lower rates, we can significantly increase efficiency. We are placing that phosphorus in the row, which is something that can be done pretty well for winter wheat. Dry fertilizer application in furrow with the drill is something that works great. And again, winter wheat really respond to that placement. And so again, if we're thinking about more of a sufficiency approach, putting just what we need this year, definitely we need to be thinking about placement to improve efficiency and use of that phosphorus fertilizer. So that's another key aspect here. Of course, again, all of these in the context of knowing what we have in the soil. So soil test is going to be very, very important this year to know what we have there. We don't have a lot of flexibility in terms of fertilizer dollars because of the grain prices. So again, having what we have there and making developing a strategy there is going to be a key. For phosphorus, I think we do have a lot more opportunities, like I say, because in many cases we can use what we already have in the soil, and this will be a year to do that if we have that opportunity. Of course, again, on the flip side, we do have some soils that is just low in phosphorus. And again, like I say earlier, keep in mind that winter wheat is highly responsive to phosphorus. In other words, if we are not putting that phosphorus, yields are going to be affected. And again, we don't want that either. So economically, there's often in those low soil test situations, phosphorus is going to be economical to apply, and there definitely going to be a return to investment in low testing conditions. So again, also another key aspect here is not just about cutting back rates across the board. We need to be looking at each field, see what we have there in terms of soil tests. In some cases, we do have opportunities to cut back, but in some cases, we do need to put that phosphorus out to make sure we are getting those yields there. And like I say, we done some of this economic aspect and looking at yield response with different scenarios of grain and fertilizer prices. And for sure, we do see return to investment, and we can make money if we do have those low testing soils where phosphorus are needed.
and really wanting to touch on this today because before the interview you mentioned you've been receiving quite a few questions of how little fertilizer can I use, and this isn't a question you're just getting from one part of the state.
Yes, certainly farmers are thinking about this right now. And again, it is a tight budget situation, so we need to be looking at every input, phosphorus and nitrogen. Those are big inputs that we use in winter wheat. And again, one of the questions, like you mentioned, that I've been getting is how much can we put at lower rates of phosphorus? And in many cases, yes. But again, emphasizing here that if we're going with some of those lower rates, placement is going to be really, really important here. We need to put that phosphorus in the row, and again, maximizing that response. Something else also to kind of keep in mind, we talked earlier about lime application as well, and just in the context of what else may be limiting yields, we need to be looking at those things as well. We do have situations where we, again, think a lot about nitrogen, phosphorus, and perhaps we have another limiting factor, which may be pH. And again, we need to be looking at those, the entire soil test, looking at all the limiting factors and see where we may get the most return to the input, whether that is nitrogen, phosphorus, or in some cases maybe lime. And so we need to be thinking that as well as, again, we think we have a little bit tight budgets this year.
And a lot of this all leads back to doing a soil test, which is something possible to be done at Kansas State University.
Yes, we do have that. Obviously, soil testing lab at K-State and obviously other commercial labs will provide this service. And I always say when we have either high fertilizer prices or low grain prices like this year, that's usually when the return to investment to that soil test tends to be the highest. The information we are getting from that soil test has a lot of value because that's going to be driving what we're going to do in the coming months. Like I say, do we have opportunities to cut back on fertilizer? In some cases, like I say, maybe we need to be putting more fertilizer in some cases in those very low testing soils. Why? Because again, we have to make sure we have those yields there, and that return to investment is going to be there in that situation. So the key moving forward in the next few months, again, soil test is going to be an excellent tool that we need to rely on.
Dorivar, I appreciate you taking the time to join us today.
Thank you.
That was K-State Soil Fertility Specialist Dorivar Ruiz Diaz. In today's show notes on agtoday.net, I will put a link to the K-State Soil Testing Laboratory. Also in the show notes will be links to 2 Agronomy E-Update articles that talk more about soil fertility when it comes to wheat fertility and wheat production. We're cutting to a short break now on Agriculture Today, but stick around because we have more for you up ahead.
This is Agriculture Today. Along with Shelby Varner, I'm Jeff Wickman. We end today's program with this week's milk lines. The USDA Economic Research Service recently published some numbers on expected prices for raw milk for 2025. K-State dairy specialist Mike Brouk says the outlook is better, and if producers have the ability to add some animals to the herd, that can help dilute some of the fixed costs and improve their profit margin.
Today I'd like to visit with our Kansas dairy farmers concerning the outlook for 2025. You know, as we finish up the dog days of 2024 and head into the fall, it's time to start looking ahead to 2025. And the USDA Economic Research Service published some numbers on expected prices for raw milk in the coming year, as well as what we've seen here in the last few months in 2024. You know, in the dairy industry here across the United States, there are some things that have been occurring in our herd as well as production per cow that has really held total milk production down. And in fact, ERS did lower the predictions for 2024 production. This will help us, hopefully, on the overall milk price, as they have actually increased the overall all milk price for 2024 to $22.30 a hundredweight. So hopefully, between now and the end of the year, we can look forward to a little higher prices. So moving into 2025, what does that look like? Well, because of the drop in production and cow numbers that we are seeing in 2024, They are also predicting that we'll see lower projections for 2025. And as a result of this, we should see an increase in the all-milk price for 2025. And in fact, they've increased their prediction for the all-milk price for 2025, adjusting it up to $22.75 per hundredweight, which is up about 25 cents a hundredweight over the forecast that was published last month for 2025. So, in short, this is probably good news for many of our dairy producers, but it may not be what you were looking for. One of the things, if you track milk production and cow numbers as well as price, there's some things that have changed in our industry in the last 15 years. As we've gone to larger and fewer farms, that has also meant that we're probably less responsive to changes in milk price. You know, if we go back a couple of decades ago, if milk price went up, it was likely that cow numbers were going to soon follow. This was driven by the fact that we had readily available heifers that we could freshen if we wanted to, and we generally had some space in our barns to milk a few extra animals if we thought it was going to be a good economic decision to do that. However, as we move to larger farms, we see that there's less elasticity in the system. In other words, if price goes up, we may not really see a change in cow numbers because many of those farms are running at capacity already. And when milk price goes down, cow numbers tend not to follow because, again, we tend to run those farms at capacity. So there's some things that are figuring into this as well. One is overall heifer supply being down, so we don't have the ability to change as much maybe as we used to. The other thing is that we have high prices for cull animals and high prices for beef animals moving into the feed yard. So this has increased the demand for crossbred calves and will tend to keep our heifer herd smaller as we move forward into 2025 and 2026. So what does this mean for your dairy farm? Well, one of the things that you might want to consider as we move into 2025, if you do have the ability to add some animals to your herd, that might be to the economic advantage of your farm, as increased animal numbers will dilute some of your fixed costs and hopefully improve your margin position, particularly if you have adequate feed to do that. However, if you're already at capacity, you probably need to work with your nutritionist and work on things like milk fat production or milk protein production so that you can take advantage of higher prices in that regard, even though you're not necessarily increasing the overall level of milk production within your herd. This is Mike Brouk with K-State Research and Extension, encouraging our dairy farmers to consider the options that they have as they move forward into 2025.
Thanks, Mike. And that'll do it for this edition of Agriculture Today. For Shelby Varner, I'm Jeff Wickman. This is the K-State Radio Network.